All right, everyone, welcome to the broadcast. We'll be getting started shortly. Just waiting a couple of minutes for folks to arrive. All right, everyone, welcome to today's broadcast. I am super excited for this conversation on feature stores and data platforms and accelerating machine learning in the enterprise. A little bit about me and the conversation before we jump in and introduce our panelists. So I am Sam Charrington. I am the founder of TWIML and host of the TWIML AI podcast. Folks tend to know me from the podcast and know TWIML from the podcast, but we also care really deeply about helping organizations deliver machine learning efficiently at scale. And to do that, we've published a couple of ebooks. One is a bottoms-up look at MLOps from the Kubernetes perspective, and others a top-down look at machine learning workflows and how they're supported by platform technologies. And across those two investigations, as well as surveying that we've done, it has become very clear that the organizations that achieve success in delivering ML, again, efficiently at scale, what I call model-driven organizations, they start first with data and making it easy for data scientists and machine learning engineers to access data. And one of the core technology elements of that is a data platform or a feature store. And we're going to dig into that topic quite a bit during this discussion. Special shout out to our friends at Tecton for participating in and sponsoring this conversation, as well as sponsoring our upcoming conference, TWIMLcon ML Platforms, which is an event focused entirely on the types of challenges and solutions that we'll be talking about today. So I'd like to jump into introducing our panelists. And I'd like to start with Max Beauchemin. Max is one of the creators of Apache Airflow from his time at Airbnb. Max, I'd love for you to jump on and tell us a little bit about your background and experiences with Airflow. Tell us a little bit about the Airflow story.
All right. Well, thanks for having me on the show, Sam. So a little bit about me. So yeah, my name is Max. So I'm the original creator of Apache Airflow and Apache SuperSet. I have now about like 2 decades of experience working around data engineering as part of data platform teams in places like Airbnb, Lyft, Facebook, Yahoo, and started my career in data warehousing. So doing a lot of ETL, ELT from before it was cool. More recently, so I started a company called Preset around Apache SuperSet, where we build in and around Apache SuperSet, and we offer SuperSet as a service. I've also recently joined Tecton as an advisor. to help them work on creating the right set of abstractions and pieces of infrastructure around machine learning, and especially like that kind of early in the pipeline components closer to the feature store. And I think in many ways, creating a feature store and preparing your data set for training models is largely data engineering type workloads. So I've been really interested in creating the right abstractions in that area, and that's why I was interested to jump on the show and spend some of my attention around these challenges.
Fantastic. Thanks, Max.
I know you asked me to tell a little bit more about the Airflow story too, so happy to share a little bit more on that. But when I joined Airbnb in 2014, by the way, congrats on the IPO announcement to all my friends at Airbnb. They just announced yesterday. But when I joined in 2014, it was clear that we're going to need a piece of infrastructure to more efficiently run data pipelines and batch processes and to help with everything data engineering there. And I joined with the premise of working on an open source project that would solve these problems. And it was really inspired from some of the tooling that I worked on and was involved in, specifically more around using similar tools that had been built internally at Facebook that unfortunately were not open source. So I joined with that premise, and over the years, I've been working really close to the ML infrastructure, data platform teams, and help data scientists kind of build the right abstractions and the right kind of feature stores and reusable components around data for training models.
Awesome. Thanks, Max. Now I'd like to introduce Willem Pienaar. Willem is an engineering lead at Gojek and founder of the Feast project. Willem, come on and share a bit about your background as well as a bit about the Feast story.
Hey, Sam. Thanks for having me. Yeah, so I'm a South African. I started many years ago, actually in networking, built a networking startup, which I eventually sold, and post-graduating from my degree, I started working in kind of traditional engineering. So automation, electronics, kind of in the industrial side. Gravitated way more towards the software side and the data side. Eventually moved over to Thailand, where I worked for a few years, and found my way into the kind of initial seeding team at Gojek, where they were just kicking off a data science team. So for those of you who don't know Gojek, it's basically a super app that started many years ago in Indonesia. At the time I joined, it was right before it became a unicorn. It's a decacorn right now. But basically, they've got like 15, 16 different products. It's mostly ride-hailing, but from that ride-hailing logistical network, they run like food delivery and logistics and lifestyle services. So you can, order groceries, you can have a cleaning person come over. There's like 16, 17 different products. And so they started a data science team there, and it was completely greenfield. They had core products running fine, but the team that initially was started there had no engineering support, and the directive from the company or the leadership was, can you just use our data to make our products better? So obviously ML is the kind of the core focus there. And so we scaled that team up, and I was leading the engineering efforts on that side. I need to help get teams into production. So we looked at kind of like the core products the company had. Obviously, like ride-hailing is a big one, and so there's a lot of like pricing ML that we were developing, matchmaking. We had food delivery networks, and so basically like food recommendation was a large part of what we did, because we had so much money, moving through the system. Fraud detection and prevention was also massive, and as well, kind of like supply and demand incentives. So a company like Gojek, it's very similar to kind of like Uber and Lyft, in that there's drivers and customers are kind of incentivized to take certain actions, and the ML affects that. So that was kind of we really focused on building these solutions. So we were not building tools and we were not building platforms at the start. We were just building, trying to lift that needle up So like conversion rate or whatever the business kind of metric was. But after about 2 years, we'd scaled that data science team up to about 50 people, but the engineering team supporting them was just about 10, 12 people. And so we realized that we can't address the needs of all these data scientists if we have to be involved in every system that needs to be developed, and we have to maintain that. And the only way to address that is through tooling and, a platform, essentially building a platform. And so we looked at the kind of like the landscape of tools that would be the highest ROI at that point. And we realized that feature store, or at least the space that we identify as where the feature store sits, is the thing that would benefit the company the most, because that's where data scientists are having the most problem working with data, getting into production, iterating, all those problems. And so we engaged with Google, and obviously looking at what Uber had done and other companies have done on Michelangelo, so Kevin and his team, and we built Feast. And that's been one of our most successful products at Gojek. We've open sourced it in early 2019. And it's, we've rolled it out to like many teams within Gojek, and it's just gone from strength to strength. And I guess that's kind of why this conversation is even happening. And so I'm hoping that we can get into that throughout the call.
Awesome. Thanks, Willem. And Kevin, as Willem mentioned, you were on the team at Uber where you led the development of Michelangelo, the company's now famous machine learning platform, at least famous among us ML infrastructure geeks. Tell us a little bit about your background and that story.
Yeah, for sure. And thanks for having me, first of all. So I'm from Germany originally, and that's where that accent's coming from. But I'll focus my introduction on how I ended up at Uber and what I was doing at Uber with Michelangelo and how we ended up at building Tecton. In 2013-14, I started a company which was called Dispatcher, and was a two-sided marketplace for long-haul truck drivers. It was really the Uber for trucking app back in the day, where every month we were shipping thousands of truckloads across the United States. And we worked on it for many, many years, and then eventually ended up at Uber because Uber was building out their internal Uber Freight division at that time. And that was a great opportunity to, within Uber, switch over to the, at that point, very nascent Michelangelo team, which was the ML platform team at Uber, that got started back in 2015, because at that point, most of the ML efforts at Uber were using mostly a lot of different bespoke tools, bespoke implementations. You would have data scientists and software engineers kind of hack things up, and over months of very heavy lifting work, eventually get an ML model into production. And Uber at that time was the fastest growing company of all times. And they were just accumulating massive amounts of data that were just exponentially increasing by the day. And most people there knew that they were sitting basically on this gold mine of data that could be turned into solving a lot of really hard problems of the company using machine learning. But it was way too inefficient to train a new model and to deploy it and run it in production. And in order to speed that process up, in 2015, they started building Michelangelo as this end-to-end ML platform that all the data scientists and all the ML engineers and the data engineers would use to really get from an ML idea all the way into production within just a couple of days. And of course, the development of that platform took us many years. In total, at the end, by the time I left, it was we were a 40-person team, and we had been working on it for 4 years at that point. But that platform led to this Cambrian explosion of machine learning at Uber, allowing tons of different teams in the organization to apply machine learning in production. And the use cases really varied from everything from supporting self-driving cars to dynamic pricing predictions to fraud detection, customer support, rider and order ETAs, restaurant recommendations, all that type of stuff that you are familiar with and that you see every time that you use an Uber product. And one core thing that stood out there was that with that ML platform, with Michelangelo, we solved two different problems that are very apparent when you try to get ML trained and ML deployed into production. One set of problems are all the problems relating to the modeling layer itself. Like, how do you train a model? How do you evaluate it? How do you manage the artifact of the model? How do you deploy it into production? And then how do you monitor it? And underneath that is the data layer, meaning how do you get access to the raw data? How do you turn the raw data into features that you can train your model on? And then how do you give these feature values to your training pipeline? And how do you ship these feature values to your model that's running in production? And Michelangelo solved both of these problems, the modeling problems and the data problems. And the data problems were solved with this core component, which we back then called a feature store, which is what then eventually led us to starting Tecton.
Awesome. Thanks, Kevin. So before we jump into our conversation, I want to make sure that everyone in our audience knows that this is intended to be an interactive discussion. You are welcome to submit your questions as they occur to you in the chat. If you're on the TWIML landing page and you don't see the chat, you can do a quick refresh and it should pop up, or you can click through to the video on YouTube and you'll see the chat window there. But by all means, we want to include you in this conversation and we hope that you drive a big part of it. So now I'd like to get my panelists on the screen and dive deeper into our discussion. And I'd like to start with really addressing the question of why operationalizing ML is so difficult. All of your companies, both former and present, have invested very significantly in trying to overcome the challenge of operationalizing ML. And I'd like to start with you, Max. You have a unique perspective on, why this is hard. Should it be hard? Will it always be hard? What was the kind of the core of the challenge that you were looking to overcome at Airbnb that led to the investment in Airflow? And, what's your take on that challenge overall?
Yeah, so I think it's pretty clear and accepted at this point that probably the most time-consuming part of the ML or the ML process or the data science process is preparing the data for training, which is essentially a data engineering problem in a lot of ways too. I think it's becoming somewhat clear too that the data science process itself or parts of it seem easier to abstract, right, and automate than the problem around data engineering and preparing and gathering all this data. I think like there clearly like in data engineering, like traceability, reproducibility, reusability, a component is clearly really important to the data science process, if you will. Airflow, I think, helped in many ways of doing the batch processing of the data that solves some of these challenges. And clearly, I would say teams struggle around this. One thing that I like to talk about too is the fact that I think it's pretty widely accepted that software engineering is a very challenging thing, and that we've had to build all sorts of frameworks and tooling to make that possible, right? And people accept the fact that software engineers are expensive to hire and that you need many of them to solve software type problems. I think in the data space, there's often this incline to think that it should be easier, right? Like data engineering should be easier. Data pipelining is this thing that it seems like one day we're going to find a solution and it's just going to solve itself. And I think that's a false assumption in many ways, right? That data engineering is as complex and maybe more complex in some ways than software engineering, because we have like all this velocity of this massive data that we have to move around and process. And it's very compute intensive to do that. So with Airflow is very much a solid attempt, I think, at helping people structure this data processing and making it a little bit more traceable, reproducible, and rigorous. And another thought is around like this idea of kind of constraint and guarantees, right? So I think like the more kind of guarantees you want, the more you have to pay off some of the constraints, right? So in some ways, Airflow enforced a certain number of constraints that was able to provide some guarantees that people really needed in the context of Airbnb. Sometimes you really need to have suffered enough to be ready to pay the price of like dealing with these constraints so you can get these guarantees because you've identified you really needed them. So hopefully I'm answering like some dimensions of the question. I think it's a pretty open-ended question too. So I'll let the other panelists talk too.
But why do you think folks think it should be easier?
I don't know exactly. I think there's like the practitioner bias is a thing, right? So as a data engineer, I tend to think that the data science process can be automated and it's easy. So maybe I think that goes the other way around, where data scientists or software engineers look at other disciplines that are related to their discipline, and you really understand the complexity of your own discipline, and it's harder to see the depth of the related discipline. So I think that's been happening in data engineering specifically more than in other places. And I think like data engineering is just at the cusp of having its moment of legitimacy, I would say. I wrote an interesting article for the people here a while ago, so it's probably at least like 3-year-old. It's called, I wrote the rise of the data engineer, talking about the rise of that role, but I wrote another piece following that one called The Downfall of the Data Engineer, that talks about everything that's really hard and complicated and makes it really hard to be successful as a data engineer and respected as a data engineer in many ways.
So for Kevin and Willem, Max is, you could take what he's saying as, it's hard and it's not going to get easier no matter how much time we spend on tools. And the two of you are spending
I'm smiling because I want to jump in.
I didn't say that though. So I think like say for software engineering, we created things like Git and testing frameworks and all sorts of like web frameworks and tools to make it easier. I think data engineering is still looking for these moments of really finding its tool set too. Yeah,
so I think your comment on the kind of understanding different disciplines is apt, because people are coming from other disciplines into data science, right? Because it's still not a discipline that's been around for super long, at least in its current form. So they have a bit of a smell test, and they know that things don't look great, right? There's still a lot of inefficiency that they can identify. So I guess you're right in some senses that you will never get or potentially you'll never reach a perfect workflow that just does everything for you. But at least it can be way, way better than it is today. And I also feel like my experience deviates from your point earlier slightly, in that I think your comment was that the data prep is kind of like the biggest time sink, or the kind of most challenging part. In my experience, for at least at Gojek and some of the folks we've spoken to, a lot of teams struggle with getting into production, even when they have it like a trained model, even when they have everything done, let's say on their notebook or on Airflow, let's say they're using Airflow. Like the organizational challenges and other challenges in getting that MVP up is, almost insurmountable for many teams, depending on the organization you're in. So at least at Gojek, that's something we saw. So the fact that you need to have multiple teams involved, you need to have, let's say, data scientists, you need to have your ML engineers helping you productionize, then you have to have product engineers integrating with whatever you built, if it's an API. Then you need to have the business folks signing off on whatever you're doing, product managers. So all these people need to sign off, and it can take months or potentially even a year. And that, you could have your model in 3 weeks, right? So that's for an MVP. I think the challenges that you highlight come when you've got that MVP up, and then you want to iterate faster, and you want to automate things, and you want to have lineage and tracking and monitoring and data quality, and you want to be able to have a nimble system that can change. But I think many companies and organizations are still stuck at that MVP phase, and they're kind of paralyzed with all the kind of decisions they still have to make, because the canonical stack for ML and data hasn't emerged yet. So I think that's kind of my view on this challenge.
Yeah, and I'd like to double click really quick on why is it even so hard to get the MVP out into production in the first place? And I boil it down to, it's the reason for that is that when you talk about operational ML and getting an ML model into production, there are typically three different components that you have to keep in mind. There is the application itself, which uses a prediction at the end of the day. And let's say it's the Uber app, which is looking to make a prediction about how long is it going to take for a driver to arrive at your pickup location. That's the application that needs to make a prediction with an ML model. That's one part. The second part is the model, which is the model that's making the prediction. And then the third part is the data or the features that are being used by the model in order to make a prediction. So all these three things, the application, the model, and the data, they need to be synchronized and they need to be developed together and they need to be pushed into production from the development environment together. And we do have decent or very good tools by now to actually get applications into production, to move from your development environment into the production environment. And that is all that the progress that Maxim was talking about that we've seen in the software engineering discipline. When you look at the models themselves, we've gotten much better there too now with MLOps platforms, with things like Kubeflow, SageMaker, and other things that make it much easier to now train a model and get into production. But the data component itself, that's still the largely unsolved part that where you have the data scientists just develop their features in Jupyter notebooks or whatever it is, and then they throw it over the wall to a data engineer, to an ML engineer, who then re-implements it and then stitches everything up together with a prediction service that actually makes the prediction, with a production application that uses the prediction, and it's just a nightmare to synchronize. And that's I think why it's so hard to get operational ML into production and developed.
But I remember from experience having data scientists kind of come over to the data platform team and say like, hey, I've built this model and I would like to bring it into production. So that those were early days before we had much, if any, infrastructure around ML. And we just take a look at the R script or the notebook and just be like, there's like, wait, you want us to put this thing in production? And we had to like basically break everything down and start over and really look at, okay, let's break it down into pieces and really start over. And I think over time, people realize that in data science, that if they wanted to get their models in production, like throwing over the fence an R script or a notebook or an incomplete notebook in some ways was just not feasible. So people started talking about, hey, what do we need to do in order to make that easier on everyone? And you know, making sure too that we're gonna bring things into production that are actually going to work and not give some surprises, right? It can be scary to take a model, bring into production, and it's a little bit of a black box too. So you need some sort of certainty that you're or like a high confidence that you're bringing something in production that's going to be solid.
So we've talked notionally about this idea of a feature store already in this conversation, but we haven't really defined it. Willem, you know, why don't you get us started off? You know, in your view, what is a feature store and where does it fit into this, you know, workflow and set of challenges that we've been talking about?
Yeah, so this question, I hope over time will become easier and easier to answer. But for many people, they have different ideas of what a feature store is. So I'll give you my definition. For me, the feature store is the layer between the model and data. And so it's an operational data system that's built specifically for machine learning. And it addresses numerous like key problems in the space around kind of like between models and data, as well as like the offline and online environments. So one of the key things that a feature store provides is it allows a team, like the data creators or the data, basically the folks on the data engineering side, to produce, create, or author new data points or features or whatever we call them, and ship them into production. So make them available for consumers without engineers hand-holding or without engineers necessarily gatekeeping. There can be some checks and balances, but it doesn't have to be as tough as you know slacking somebody and waiting for them. A feature store provides consistency of access to data. So if you're on the consumer side, if you're a system, or if you're, let's say, just somebody in a notebook, a feature store gives you the consistent, temporally correct view of data for training a model, and for if you're shipping that model into production, also on the online side. Feature stores, optionally, depending on the feature store, because Feast doesn't do that today, also provides a way to author the transforms and execute the transformations or pipelines that produce the features. So either producing it and storing it into an offline store, or producing a temporary data set in an ad hoc manner. Feature stores also allow sharing of features. So if one team creates a feature, the next team can copy and fork that basically, and they can just create new features from that, or reuse existing ones, and they can also inspect ones that have already been created and understand the intent behind that. And then finally, feature stores are not just a batch system. It's not just an offline system. It's not just a pipeline called something differently. It's actually a system like running in production. And so it's something that needs and produces monitoring data and has instrumentation, so that your production operational teams can run their systems and integrate with the feature store and have confidence in the data being fed to models. Because something that we found at Gojek was that a lot of damage can be caused by a single feature being out of bounds, or just the distribution shift. So that's one of the key aspects that the feature store also provides. Yeah.
Awesome. So Willem described the feature store as being this interface between the data and the model. Kevin, I've heard you and your colleagues at Tecton describe it similarly, but slightly differently, as an interface between the data engineers and the data scientists. So more looking at the people as opposed to the artifacts. Am I capturing that correctly? If so, elaborate on that perspective. If not, correct it and elaborate more.
No, you did pick up history correctly. We did indeed describe it as the interfaces between data engineers and data scientists first, and
but that's a historical view.
It's still an accurate view, and I think they're not mutually exclusive. I think, and the reason why I'm saying that is that the feature store does, when we say is the interface between the data scientist and the data engineer, it allows data scientists to very easily define feature definitions and feature transformations using the languages that they understand very well, like their SQL, their Python, really just the stuff that they use on a day-to-day basis, and then give it to the feature store, which then behind the scenes fairly automatically actually spins up the data pipelines and automates a lot of the boilerplate work, the grunt work that sometimes data engineers have to manually still do on a day-to-day basis for them, so that they're unblocked. But the data engineer is typically still involved. Like when the feature store is first set up, they're involved in making sure that it is connected to the right data sources. They're also typically the ones who are providing individual building blocks for the data scientists that they can then reuse to develop their higher level features. And so it would be information, say, like if a data scientist wants to build a feature against a raw data stream, then the data engineer would put the building blocks in place that define, for instance, how long should a streaming operation wait for late arriving events. That's typically like a data engineering, data infrastructure type level of detail and information that only the data engineer really knows best, and the data scientist should be completely protected from and removed from. And so the data engineer can configure all these details, put these building blocks in place, and then the data scientist can build on top of these building blocks to build the higher level abstractions and higher level feature definitions that then the feature store automates, and where it then runs the data pipelines actually in production. And so that's how it's an interface between the data scientist and the data engineer. But it is also, as Willem just described, the interface between the model and the data, because the feature store does serve the data, the features to the model running in production. And it does serve the data to the training pipeline that produces the model artifact in the first place. And with that, I'd also like to highlight that the name feature store, I think, is somewhat counterintuitive, because like it says store, and the first time people hear the term feature store, they would typically think, oh, it's probably like a database or something like that where I'm storing feature data. And that's just not what it is. It is much more than that. And I wish we had named it something else back in the Uber days when we built Michelangelo, because it does help you automate the data pipeline. Yes, it does oftentimes actually just optionally store the feature data, but that's just one component of it. It serves the feature data as well. It monitors the feature data, and it makes sure that the feature data gets produced in the first place.
So what's a better name for it than if you say you wish you had named it something different?
We thought about feature platform, data platform for machine learning. I think those are actually more accurate, but by now, like, feature store has become more of a term in the industry and part of the known ML stack, where it may even be beyond the point of return, so to say, to try to change the name. And now it's more making sure that people, when they hear and think about a feature store, they recognize, okay, it's not just about the storage component, but there's much more infrastructure automation around that is actually much more important than just the storage component of it.
The aim is having an interesting kind of double entendre to it. There's store from the perspective of storing the data, but also store from the perspective of commerce and the sharing and allowing for feature use. Yeah. What's how much of the feature store story is that feature reuse? Is that a big part of it in your estimation, Kevin?
It definitely depends on the organization and the size of it. If you have, the more data scientists you have, the more different use cases you have, the more sharing becomes a big part of it. And we're working with some very large Fortune 100 companies in the US, and they absolutely care about sharing of features. And they're super interested in, hey, how can I develop a feature just once in team X, and then have a data scientist in team Y reuse this feature, because so much work went into first building this feature, testing it, making sure it's valid, and contributing it to the feature store. And then they just want other people to reuse it over and over again. However, in a smaller organization, a small team, where it's just a handful of data scientists sitting next to each other, the primary problem that they care about having solved is, how do I actually get the data into production? Like, that's my main problem. I don't care yet about the sharing that comes afterwards. I mostly care about getting the data pipeline spun up, having it be run reliably, having it be monitored, having it produce the feature values, and then serving those feature values. And for them, the sharing aspect is a distant value prop that they will care about at some point when the data science organization has grown to a reasonable size.
Yeah, I would say on top of reusability, right? Like, I think the feature store can provide a lot more guarantees around metadata that are really important around traceability. Who's the owner of this feature? Who built it? Is it on time? Can I rely? What's the data lineage behind it? I think those are a set of guarantees that people need when they want to use or reuse a feature, or even just kind of introspect a model of, like, who built this model, where did it come from, what was it trained with. And I think, like, this rigor becomes really important as you've suffered from, like, kind of missing it, right? So if you have a model into production that's making bad decisions and it's costing money to the business, or creating bad user experiences, you're going to want to troubleshoot it. And if it lives on if the model and the model training lives on someone's notebook on their laptop, who has left the company, is just this explanation. It just doesn't work very well. I think for me, talking about the feature store, and there's clearly, like, feature engineering and feature related infrastructure on the data platform, but looking at the store per se, you can kind of think of it as a subset of the data warehouse. Where data, it's a little bit of a, not microcosm, but a little of an island inside the data warehouse that offers kind of the guarantees and the metadata that you need to support ML type workload. One thing that's interesting is this idea that of what I call entity-centric data modeling. So if you look at the history of data modeling for analytics purposes, right, there's dimensional modeling. This is very, like, popular kind of methodology that became more popular about, like, 20 or 15 years ago, right? The Raph Kimball books. So dimensional modeling is about having dimensions and facts. And I think for the purposes of machine learning and training models, really, we want this, for the dimension or the entity, to become really the center of it all, and, like, not only have maybe qualifiers or attributes of the dimension, but also, like, bring in denormalizing some of the metrics and the time series inside or closer to the entity per se. And, like, the feature store is just one place where entity-centric data modeling is interesting. There's other areas, like, for A/B testing purposes, right? And then I think around like metrics repositories in some ways sometimes will tend to be entity centric. When you look at companies like Uber or the ride sharing type companies, like the driver and the rider become like these really important entities where you want to bring all of the data kind of around as a dimension of that entity that's really kind of strong and powerful, and just this very centric business entity.
And Max, were you responding to Daniel's question in that response, or are you just psychic? Because he was talking about some very similar things, the Kimball methodologies, and his question was about prioritizing and planning for feature store development and the relationship between that and data warehouse methodologies.
Yeah, that's an interesting question, right? Like of where does that fit in the data lifecycle? Do you build your star schema first and you do dimensional modeling and then you build your feature store on top of that? Or do you bring kind of more raw metrics into your feature store, maybe directly from your analytics events pipeline or your database scrapes? To me, it's kind of unclear, and it really depends on what you care about. One thing is for sure is if you care about real time, you're not going to have the luxury to think about dimensional modeling, right? You're going to have to think about bringing kind of raw events, enriching them, and bringing them to your feature store as real-time events without really applying kind of all that batch processing knowledge. But I would say if you were to look at the data flows around, like if you were to do a diagram of your data warehouse with your feature store somewhere in here, I think the data might be coming from everywhere else in the warehouse, from raw ingredients to heavily processed ingredients as well.
It's actually interesting that you say like a feature store for you is a subset of the data warehouse or
the lake,
or the data lake. And to me, it's actually more. It's like it's outside of it, and it uses the data warehouse or it uses the data lake. Like it orchestrates a lot of the data pipelines that read raw data from your streams like Kinesis or Kafka, from your data lake, from your data warehouse like Snowflake and Redshift, transforms it, and then makes it available for online retrieval as well as for offline retrieval. And when it makes it available for online retrieval, like you can't really store it back in the data warehouse or something like that, because you need to be able to fetch these feature values at really high scale, super low latency, and that's just not what like a commoner data warehouse is built for. And so I view the feature store, whatever you call this thing, like the really more is that it orchestrates these different key components of a data architecture, of which a data warehouse or a data lake is just one core component.
Yeah, I think that's absolutely true. Especially like you need key value, kind of key access, like key retrieval. So I think from that perspective, you either need to from your data warehouse kind of elevate, have kind of these data elevators to bring them somewhere where they're more accessible, where you can kind of access them by key. But it is it can be seen as like it's definitely part of the data platform. Is it part of the data warehouse? Probably not. It's like a subsystem.
Yeah, I also think oftentimes it can actually start in an organization as a subset of the data warehouse. In organizations where you typically only have batch workloads, like if that's all you care about is batch calculated features and batch predictions that you're running, then oftentimes it's totally good enough to define your feature transformations using, say, dbt. And then you run the transformations directly in the data warehouse. And then you have a convention around the tables in which you're storing your transformed feature values, where the data scientists then know where to find them and pick them up for their batch predictions. And in that world, if it's all just batch data sources, where the raw data is already in your data warehouse, it's all just batch predictions, then I think it's totally fair to actually say, hey, my feature store is just an island within the data warehouse, and I don't need specialized tooling. I use dbt and run that in there, and I'm good, and I'm off to the races. But then later on, once you layer in other types of data sources, the streaming sources, or once you actually want to go into the operational world, once you want to get out of the analytical offline world, that's when a data warehouse by itself is just not going to cut it anymore. You need something like a Tecton or a Feast.
Yeah, I agree with Kevin. And I think it's even possible if you have the data really in a transformed state to not have any island there, and to have you can even have a pure online feature store in theory, right?
Yeah.
I think I have this like Airbnb kind of centric, Airbnb 2016 view of the world was a lot of batch processing too. And a feature store was largely, like a batch feature. I think it's interesting to talk about how the two relate in many ways too, where you have like your real time and your batch. being kind of different parts of your feature store too.
Yeah.
I want to pull in a couple of audience questions that are raising an interesting issue, the same issue, and that is centralization versus decentralization with respect to features in Evan's question, and with respect to ownership of modeling in Daniel's question. How did you manage kind of decentralization versus centralization at Gojek, Willem?
So that question just popped up very quickly, so I'll answer kind of at a high level. Gojek, I think for the first 3 years that I was there, was very democratic for better or worse, and so there was a lot of that kind of negotiation in order to get into production, and teams decentralized defensively, and so you kind of not have external dependencies if you want to ensure that you have control over your own destiny. And so Feast was originally developed as kind of like a monolithic centralized system, and then we decided to decentralize. And so we'd have a central registry, and then we said we'd have decentralized serving layers, even decentralized warehouses. So you can kind of push to your own tables and store it in your own VPC, and you control your own serving layer. And for some teams, that was like a big thing. It was a big deal. Other folks just wanted a centralized managed service. They didn't care about in fact, they don't want infrastructure. So it was very team specific and organization specific. And I think the majority of folks that we've spoken to they need the decentralization. But when you do need it, then it's important. But it's mostly kind of like a defensive thing in organizations where there's a lot of process involved, and you need kind of more finer grained control. Does that answer your question? Or is it more on the feature definitions as well?
No, I think that's a good take. Kevin, any thoughts to add to that from what you've seen?
Yeah, definitely. I think centralization versus decentralization is a really interesting question, because oftentimes people think, oh, I really want to have things be decentralized because that allows me to move much faster, get things into production much faster. I don't have to synchronize with other people. I don't have to follow any guidelines. I can just do whatever I want and throw it out there, and it'll all just work just fine. And what we've seen with Michelangelo at Uber specifically was that actually a centralized platform can somewhat counterintuitively oftentimes do the exact opposite of what you'd expect. It allows you to get into production much faster than you would on your own if you just hack things up on your own on your laptop with whatever framework, whatever tool you want. And so what we were able to accomplish with Michelangelo was that these efficiency gains that Michelangelo will provide people would voluntarily then come to the centralized platform and maybe give up on some of the flexibility that they are used to on their laptop for all the efficiency gains that they have by using this now centralized platform. That's one thing that we saw also with Tecton now. We have actually worked with Atlassian. We have a case study that talks much more about this in detail. But there we initially started working with this one team at Atlassian, which had initially built their own feature store. And it was in one team, and they realized how hard it actually is to build this thing, to maintain it, keep it up and running. And then we came in and replaced their internal feature store implementation in this one team. That's where they started. And now they've been growing it out, and other teams in the organization in Atlassian have been starting to adopt it and use it. And now it's becoming much more of like a centralized rather than decentralized feature store in the organization.
Just one thought around the feature store specifically is that it's an incrementally adaptable technology, right? So there's nothing that says you cannot have some features that are in the store and some features that are on your laptop too. I think it's really important for ambitious pieces of technology to offer kind of an on-ramp that can be slow, and maybe an organization like Airbnb would really focus on the core entities and the core features around these entities to really make sure that these are really solid and they can be reused. Then there's this long tail of features, that are perhaps used in only a single model, right? Or they're only predictive in some cases. And should those live on the feature store? I think if the feature store is well built, that becomes just kind of a normal hygiene and mechanic to use it. If it should provide abstraction metadata that you value, and then allow you to have a uniform way to do feature engineering, which is like tremendous value for for the organization.
Yeah, I think that's a really good point, because oftentimes people have this wrong notion that they think it's an all or nothing with a feature store, and you're absolutely right that it can be a mix and match.
Max, once again, ahead of our questions, Evan asked something that you spoke to in terms of managing the balance between high priority use cases versus kind of more common needs across the organization's use case. And sounds like one of the answers to that is that the feature store doesn't have to be all or nothing. All the features don't have to be in the feature store. You can kind of stage that as appropriate.
Definitely for batch. I don't know if for online there might be more of a like gravitational pull to do it all in one way. Maybe Kevin can speak more to that, right? Like, so could you mix, real-time features that are coming from kind of more homegrown versus a feature store? It seems like it'd be fairly complicated to do that.
Which also gets to another question that came in about unifying batch and streaming features. And is that even is that the direction that you should go? Kevin, want to take all that on?
Let's do it. Yeah. So the unification of batch and streaming features is actually one of the core capabilities of a feature store, because a feature store, at the end of the day, it decouples the feature production from the feature consumption. So you can have these batch pipelines that are separately running from the streaming pipelines that are processing all the raw data coming from the batch source, like your data lake, or from the stream source, like Kafka. And then they store the data in the feature store, which is for online serving purposes, the key value store, like your Dynamo, your Redis, whatever it is. And then you've got your model running in production that needs to consume these features, and it reads them, not from the stream, not from the batch source, but it reads them from the feature store, which under the hood just returns these pre-computed feature values from the key value store. And so that's how it enables the unification of streaming and batch features.
So for folks that are interested in the feature stores and some of the processes that we've been talking about, the questions will pop up. Should they build their own? Should they use something in the cloud? Should they use something that's based on open source? And Tecton and Feast recently, as in yesterday, made an exciting announcement on this front. Kevin and Willem, want to share a little bit about that?
Sure, I think I can jump in on this one. We're joining forces. So together we believe that, so I'm leaving Gojek and I'm joining Tecton. And we believe that together we can build like best-in-class feature store. And Feast has just entered the Linux Foundation. And so we'll be heavily focused on in Feast, together with Tecton and the Feast community and the major contributors to Feast, building the best-in-class open source feature store. And at the same time, putting all our heads together, the greatest minds in this kind of niche industry, also building best-in-class enterprise feature store. And for us, this has been like a major kind of strategic decision for us to come together, and the timing couldn't be better.
Kevin?
Not much more to add than that, except that we're extremely excited that Willem is joining Tecton, that Feast is now part of the Linux Foundation. And yes, it's a huge and very important strategic priority for us to invest very significant resources behind Feast. And of course, continue to invest very significant resources into Tecton to really provide ML teams out there with a choice between, hey, is an open source feature store really what you wanna use? Is that maybe much more appropriate for your use case because maybe you have a smaller team and you really love to manage and run the feature store on your own, or you really need to hyper customize the feature store? Then Feast and an open source feature store makes way more sense for you. Other enterprises, they may love the idea of having a fully managed feature store that's running in the cloud. Somebody takes care of it. It comes with SLAs. And for them, there is the enterprise offering. There's Tecton for them. But yeah, we've come together to provide basically the full spectrum with the best-in-class choice of a feature store that they can use for their use cases. And we couldn't be more excited about it.
To the question of whether people should build their own, or so with the work that I've done around open source, I would urge people to really look at communities and try to join communities as opposed to starting necessarily their own thing. Or if you want to, you should really look at what is out there and try to join forces with people. If you do find that you want to build your own thing, you should probably do it under the umbrella of an existing community or maybe close to existing communities. Also, if you do, please share your reference implementation, share as much as you can so that we can all learn collectively from this, right? To really make progress and talk about this field really maturing, we're going to have to work together and not in isolation.
Yeah, I agree with that. I think that there are very limited cases in which you should be building. I think there's still a good case for building your own solution if it's a learning exercise. Or if maybe you're at Google scale and there's a lot of intellectual property that's wrapped up in whatever, your use cases are extremely advanced. But we have enough environments in the open source world in which you can contribute to an existing solution. There are many different implementations out there. Obviously, I'm biased. I want folks to jump in on the Feast side and help us build out this kind of best-in-class open source feature store. But I think there are not many teams that should be building this on their own.
Got it.
Yeah, it's a lot more motivating to build things in the open and to share, right? And then the power of the group is tremendous.
I want to pull in another couple of audience questions as we close out. They are both related to adoption. And this first one is from Gene. What problems have you seen with organizations trying to get feature stores adopted? And Charles's question is, how much integration is required to adopt a feature store? So what is the path for folks that want to embrace this idea of a feature store and make it a part of their ML flow?
Yeah, the feature store platform itself is really meant to be incrementally adoptable. And so it's not an all or nothing thing that you have to bring in-house. You can, for instance, start by only running the serving component and maybe the feature metadata component of a feature store, and continue to run the transformations outside of the feature store. Like maybe you have your Airflow pipelines or wherever you run your pipelines that you're happy with already, where it's very easy for you to contribute a new data pipeline to. And then there is an interface between that Tecton exposes and that Feast exposes, where you can have your Airflow pipeline just push pre-computed feature values into the feature store. And then the feature store is now really just meant as that interface between the model and the data, where you can then later on in production just retrieve the feature values, or have your training pipelines retrieve the historical feature values in order to train the model. And that's what you would typically start with. And oftentimes you'd also just start with one use case with a handful of features and one team. And then once you're successful, you'd have more use cases being onboarded onto it. And eventually we typically see that then companies really realize also the benefits that come from having the feature store also manage your transformation. And then oftentimes you'd see new features, especially the harder ones that run streaming, transformations and whatnot, be entirely managed by the feature store. But there's a path to very incremental adoption onto a feature store.
There's also a need for kind of a feature store evangelists in modern data teams too, right? So that role, maybe the people we're talking to today, I don't know exactly who you are, but I think the world or your organization might need an advocate, an evangelist to say hey, let's do things right. Let's build things we can reuse. Let's provide the metadata that we need so we can kind of all work together and create a consistent piece of infrastructure that we can reuse.
I think the strange thing about a feature store is that it can actually add value in multiple ways, right? And so you just said reuse, but often, if you're just getting a model in production, it's an online model, you're going to have to deploy infrastructure, right? So you're going to deploy Redis, and you're going to build your little API, or you're going to actually interact with that Redis or whatever online DB. You're going to be synchronizing data. So why do that if you need to? You can just deploy Feast or another feature store and get up and running. So I think that first value prop is just there's already a solution for the specific use case. But then there's these other value props like the metadata tracking, and if you have materialization and transformations in the feature store, or reuse, or the metrics, and all those things that come with it, those are like additional value props. And I think in terms of adoption at Gojek, we found it easier to start with those kind of online cases. And for Feast, because Feast didn't address the transformation at the start, our toughest customers were always the kind of like more of the Airbnb ones, the kind of batch ones, where they have their workflows, they have everything already figured out, their data quality set up, and those are what like harder ones for a Feast to solve, but not necessarily for kind of like an enterprise feature store like Tecton, where that has that functionality.
Awesome. Well,
I just had this thought. Wanted to submit a question for the panel if it's not too late. But talking about like whether feature stores quick whether feature stores can be used for non-ML use cases as well, right? Like state machines and other, like, was this user canceled on recently? The feature store can answer that question. It might just be an if statement as you build a page on a website. But I don't know if we have time for this question.
The short answer is yes, and we actually have one customer who uses us in exactly that way. And then, of course, you only care about the online serving component. You don't care as much about the offline serving component, but it is something that you can use it for.
Awesome. Well, we are out of time. If you are in the audience and still with us and would like to hear more on this topic, go ahead and shout out in the chat, and maybe there'll be a part 2. But at this time, I'd like to thank Max and Kevin and Willem for your participation. It was a wonderful conversation. Thank you all for listening in. If you asked a question and we didn't get to it, we will get those questions over to our panelists and try to get some answers for you. The video here will be available immediately or very quickly on YouTube. So if you missed anything, just check back on our YouTube page or the webinar page on the TWIML AI site. And we look forward to having you join our next discussion. Thank you. And thanks once again to Tecton for sponsoring this discussion.